being a person who's kind of barged in and taken away one session, I will kind of try to keep it short. Right? I'm not going to take the space for that session, but I'll try to spread it into two parts. I'll try to give an overview of what we are doing, some of the solutions that we're working on, and then I will leave it open to the audience, to a round of questions and possibly around areas, where we could kind of collaborate on, right? So in this room, I want to know how many of you are aware of blockchain? Okay. How many of you worked on cybersecurity? And how many on open source? Okay, so we got a good mix. And so some of the things that I'm going to talk today are around these three areas, but predominantly I'm going to talk about solutions that we actually work on, right? So I'm going to also start with a little bit of introduction about myself. So these are my areas, that I'm a tools person. I build tools, and in that process I ended up making 3 platforms, okay, and they happen to be crowdsourcing platforms which we've used exhaustively inside our organization. And if you've heard of Topcoder, which is one that we use for crowdsourcing, so that's one of those platforms. And I have few patents, and I've done workshops in IITB where we have kind of seeded some of the projects that we're going to talk about today. So just to start with, what is blockchain? So blockchain, the way I see it, it is software. It is nothing more than software. It's protocol that is written so that your data that you actually put into it remains there forever. That is what it means by saying it's immutable in manner. So if I'm going to have data which I put on blockchain, the understanding is that nobody is going to tamper with it, right? So that is the basic idea. And there is a software, this protocol layer, which does this job for you, and you're basically kept completely abstract of what happens underneath it, right? What does the browser do? Yeah, and gives you an abstract layer on top of your HTTP post. So while you're using the browser, you don't know what's happening underneath it. Same way, this is a protocol which gives you the confidence that you do whatever out here, it is going to remain there and it's not going to get tampered, right? So that's what it is. And this is a game changer, because for cybersecurity, you need data, and you want to be very sure that this data that you have is genuine or authenticated. So these are the 3 areas that I'm going to kind of focus on. So when I look at blockchain as a vast technology, can I now start using blockchain for protecting identities? Can I use it for protecting data? Can I use it for protecting critical infrastructure? So if I can do these 3 things, I make an impact in the cybersecurity space. So this is how blockchain becomes relevant here. And how many of you have bought things on Amazon? Right? How many of you have taken an Ola ride? Oh, okay. Did you know there's an algorithm in the back? Right? The algorithm in the back. Did you know that algorithm is being tweaked regularly? Right? So that's where I'm going to come to the next thing, which is the synergy between the AI bit. So this is AI. All these algorithms running the back, doing stuff for you, is what we're going to talk about, in terms of how can you ensure that the Ola rate, whatever is coming in, is genuine. After 2 minutes, I might actually get a different rate. The person next is getting another rate. How do I know that algorithm is like accurate? It is 100% spot on. How do I know there is a delivery of Amazon, and possibly Amazon would prefer not to make the delivery and say that the packet is lost? I'm assuming, based on some cost factors, wherein doing a reshipment may not be a viable solution, right? So these are questions which come up when the entire system has got automated. So when I have AI, it is not a human being who's making the order. It is a bot, it is a machine with whom I am going to interact. What is my confidence that the machine is going to always behave the way it's supposed to behave? There are possibilities where an algorithm would determine whether it should go to person A or it goes to person B, right? So this is where we are looking at AI. AI needs to kind of explain. It needs to say that I am true to my algorithm. So if I'm an Ola, I want to prove that I've done it right, right? So where is the system to do that? So that's one question. The other thing is, it increases the efficiency of sharing data. My data is with somebody else. How do I know the data is with this person and it is only with this person? How do I know that the bot didn't actually take my data and generate an email which I didn't intend to send? It sent an email which I didn't even think it would send, right? How do I now start buying things? How many of you heard of Singularity Net? Singularity Net? Yeah. What's it?
It's AI explosion.
It's an AI explosion. It's an AI explosion wherein people are trying to integrate various pieces of artificial intelligence and they're trying to cook up a system. They're going to create a system with the mammoth thing where you could get AI on demand, right? I think the speaker just before in Cocoon, he was talking about Dr. Roshi, who made an autonomous car. So the autonomous car is a combination of so many things. Now if I want to kind of pick and choose some of these things in a marketplace, what AI elements I want when I'm going to kind of design a system, that is when you want to actually have something which is more trusted. If I'm going to buy an AI good, if I'm going to buy a sensor which is smart, if I'm going to buy an algorithm from somebody, if I'm going to buy a code fragment, so it's pretty much possible that you start now purchasing code fragments today. If I do crowdsourcing, what do I crowdsource from a developer? It's a code fragment. How am I actually thinking about validating it, ensuring that this person has given me that code fragment, right? So that's where your marketplace is now. So it's not about open source alone. It is all about how do I make it a commodity and make it available to a lot of people. The other thing is trust. How do you trust machines? How do you bring in trust into the system? So this is something that we'll talk about. The other story that is happening and very much influencing all this is, you can take a look at, I think it's right at the bottom. These are two stats which have been come out from a report which says 65% of companies are contributing to open source and 59% of them are doing it for competitive advantage. A company using something for competitive advantage, as long as it is competitive, they will do what they're doing. So there is a if and but, when should I actually use it, right, and what. The other thing is, when I talk of blockchain, with the current number of projects, if you just go to GitHub, there are 90,000 projects in blockchain, close to. I mean, this is a year old, but I'm just trying to say 90,000 projects. Out of this, only 8% are the number of projects which are kind of having good number of committers. So this is something which is happening in the background, and the ecosystem is shifting drastically, where we are moving towards a model of consortias. A model of consortias is a group of companies, a group of organizations coming together for a common purpose. And how do these organizations ensure that they are actually in sync? By demonstrating their ability to actually share resources, by saying, look, these are my developers, this is my code, this is what I'm working on, right? So this is a model. And then you would have heard of incentivizing crowds. I would give a monetary amount, I would give a bug bounty, I would give things like that. So these are things which are actually round the corner. So this is something which I would say as another reason why a technology like blockchain comes into the picture, because with the number of projects that say that they are into blockchain, how do you kind of distill, figure out which one is relevant for you? So if I'm going to build a solution which is blockchain specific, these are the benefits I see in it. It gives me real-time visibility to a degree. It brings in efficiency. It enables me to collaborate freely. And the bottom line is about trust. So these are the 4 dimensions why I would actually have a blockchain based solution coming into the picture. Now, mind you, when I say efficiency, I'm not talking about the speed of transaction, I'm talking efficient transaction. Something which used to be manual, I might actually have a contract doing it for me. When I talk of real-time visibility, it means real-time which is good enough. I'm not talking of nanoseconds, right? Trust is like I can go back and verify. That is the trust dimension here, right? So anything, I mean, I talked about 90,000 odd projects out there in GitHub. How do I evaluate and figure out which of these are the ones which are relevant to me? So these are the guiding principles that we use basically to determine whether the project is a suitable blockchain framework. So typically what we say is it should be distributed in nature. It should have some sort of storage which is distributed. It should be peer-to-peer. It should support transparency and it should be pseudonymous. It should be irreversible in nature. That is, I do something, I cannot actually undo it. It must be programmable. That is, I can actually control it. So if these things are there in that framework, or as I call it, a distributed ledger system, it actually qualifies to be something what we can call as a blockchain. Pseudonymity is, I'm able to get back the thing which I previously had. It is not anonymous. I can always get back to what I had previously done if you have the right permissions to do it. Pseudonymity happens at the protocol layer of transferring something. Yeah. Pseudonymity happens at the protocol layer of how do I transfer something. Irreversibility is with respect to the transactions. So when we discuss further, so one is about the encryption logic is where this comes in, whereas this is about the transaction per se. Okay, so you could, yeah. So in the interest, yeah. So in the interest, she had a doubt on what is the difference between, yeah. So what is the difference between transparency and pseudonymity? So the difference is that, in case of transparent, it means it's all visible to all. Pseudonymous means it is exactly the same thing, but then it is not visible to all. So for example, if it is an ID which has been encoded and given to you, this is the ID, but you do not know, the actual plain text details of it, right? But you can get the same thing back from that. Whereas if it is completely encrypted and made anonymous, you cannot even get it back. It's not irreversible. So this is how a blockchain network would typically look like. The yellow ones are the observer nodes. The ones that I talk about, as observer nodes are the ones which are used for scaling up a network. So the ones in the blue, the dark blue ones are nothing but the validator nodes, the ones which does your bulk of your work. And the validator nodes are the ones that we throw into the network so that they can actually scale up a network and you can actually do stuff. The transaction processing part is nothing but this is where your contracts, your validation, your writing onto the blockchain network happens. The next piece is an algorithm. The algorithm, where I mean, it is the algorithm which determines who is the person who is going to write onto this network. So everybody cannot write onto a blockchain network. The person who can write onto the blockchain network is determined by this algorithm. The last thing is, we talked about pseudonymity, encryption. So that is where it has to be peer-to-peer. So the last thing is the peer-to-peer network bit. So I cannot say every solution can be a blockchain solution. So if I want to go to blockchain, there are these set of things that I need to first of all debate. Should a system be centralized or should it be a decentralized system? Am I removing an intermediary? So let me explain this. I have a SAP application in my enterprise. It is a centralized application. If I remove that and have a decentralized application, is it justified? So you should have these questions before determining before I go to a decentralized mode of application. The answer is it depends. It depends on how much you're using your centralized application for. The next thing is cost of trust. Trust comes with cost, right? So when I actually say cost of trust, what I mean is, do you believe I am ready to pay so much more to get a guaranteed assurance from, say, Amazon that this delivery will happen by so and so time, right? So I'm paying an additional amount. Why? So that I'm actually getting some additional service, right? The same thing is played on to trust here. Okay. The remaining is slightly more involved with respect to what is a public network, what is a permission network. I will leave it at that, and I will let some of you ask any questions if you have any questions on some of these other points. So these are the basic points based on which you would kind of determine whether you should go for a blockchain based solution. So the choice of business model is very important because that determines who is going to run it, how is it going to be sustained, how long can you do it, how would you incentivize a blockchain network. You don't just start a blockchain network, you have to continue to invest into it. So that is where the investment piece comes in. Public permissions are typically based on whether it is supposed to be offered to anybody in the world, or is it a consortia or a closed kind of a network. So broadly there are 3 themes in the blockchain space. So the themes that I would consider for building solutions in the blockchain space are, you can take the blockchain network and build services on top of it. So that is one. You can run a blockchain network, that is another kind of solution, right? The last one is about building tools for blockchain. I have a blockchain network, can I actually see whether the blockchain network is secure or not, right? So these are broadly the 3 areas in which you can actually develop solutions, and all these are in the cybersecurity space I'm considering here.
Intensive, right? So if I add blockchain again,
right?
So whether it will again increase that compute and performance level.
Performance of it. See, when I talk of blockchain, blockchain is about scale. Anybody's computational power is being used, and again it depends on the use case. So AI based application would be something like an off chain thing which will never be written onto the blockchain in any case. So whatever you do in AI will continue to be where it is, so we are not bothering that. All what we are trying to do is that we are trying to ensure that we are putting some placeholders so that some network, some information can be repurposed for building trust into the system. So they're not adding up to an additional load of a system. This is something where a lot of participants are participating in it. The incentive is what is driving them to participate. So it is not, unlike, I don't have to size for a system like this. People are giving me money to get onto this, right?
One more question
Yeah.
on protocol. So when you say protocol, whether it will be point to point or shared ledger protocol?
Right. So when I say protocol, it is the entire stack. It's the entire stack. So it starts right from how I'm going to do the peer-to-peer, how I'm going to do my encryption, what are the kind of apps I'm going to have. So it is the entire stack. Like if you have a TCP/IP stack, exactly this is going to be another stack altogether.
So whether you consider Merkle tree when you decide about the design?
See, I don't, so okay, in the open source world we don't build anything. We repurpose. We go scouting. I told you that already 90,000 odd. So it is criminal in this thing to build something new. So I would definitely go and pick something which is already there, and as long as I am going to remain open source, I would definitely piggyback on something which is proven. So my energy is going to be spent doing this. I would be doing independent verification of what works, what is not working, how can I repurpose it, how can I fit it, how can I get it back into my system, right? So this is what it is. So 90,000 projects, and then still that's not the end of it. People are still making it. So we don't want to get into that, right? So these are the target market areas for blockchain based systems. So one is definitely protecting identities. So how do I ensure that a person's biometric identity is not misused? An employee within an organization, how do I ensure that your data is not used for something else? Right? So these are questions which come in. There is an interesting idea around a decentralized identity, and there's something called a self-sovereign identity, wherein the individual has control over that data that he's giving. So you will have access to when to use it, where to use it, how is somebody supposed to use it, all those details you would have. And putting all this information onto the blockchain will give you the proof of that. So if somebody has used it in whatever way, trust me, it is going to be there in your network. So there is no way he can actually work around after he has misused your data. So that is what we are trying to bring in here. Data integrity is about how do you ensure that a system which was of type X today, tomorrow after some period of time it has not changed. So I leave markers of how my system was into the network and I try to cross validate it. A simple example of the flat world I would say is if I have a file and I have a CRC check to a file, right? The CRC check is nothing but a cross verification of everything is right. Similarly in the blockchain we have a Merkle tree. So the Merkle tree is nothing but a cross verification. So I could possibly do that with respect to infrastructure, assets, you name it, anything which I want to basically protect, right? The same goes with respect to critical infrastructure. This is a happening space for very different reasons, because how many have heard of serverless architectures, right? So the essence of serverless architecture is that all that you have is code. So now we were protecting all these IT boxes and firewalls and things like that. What happens to the code which is floating around? How do you protect that? I could spin it up on Google Cloud Platform, Azure or AWS or any one of these platforms. So that's where when I talk of this security, it is no longer about the firewalls or the perimeter of my organization. It is a whole world. My organization is no more within the four walls of my whatever. So when I have content on a serverless architecture, if I have content which is floating around, I need to protect more than what I'm already protecting, right? So that is where blockchain comes in. So these are some of the areas which I'm just calling off. Before I jump into this, any questions on this? So I could kind of.
Excuse me. So when it comes to blockchain solutions, we always relate with the cryptocurrency or the digital transactions.
Right.
So is it only that, or can you just throw some light on that?
So I didn't talk anything about cryptocurrency.
Yeah,
yet.
but we always relate to cryptocurrency.
Right. So why is it that people associate with cryptocurrency is because the buzz of currency, right?
Yes.
I mentioned blockchain generally is a distributed ledger technology. So the technology is the essence. So anything where you can apply a distributed ledger, blockchain is applicable.
Any kind of a ledger.
Any kind of technology. Wherever you feel I can use a distributed ledger, I should be able to use blockchain. Right? And I'll come back to this 5 principles. If you want any one of these 5 principles there in that design, that is when you are kind of able to visualize a solution using blockchain. Yeah.
This PK alternative something you have written, right? Blockchain.
Previous one?
Yeah.
Okay. Yeah.
Blockchain based PK alternative.
Right.
Can you explain it in detail?
Right. So I'll give you, detail I will restrict it to what it matters, right? See, the PKI is the, today in security, right, PKI is the basic public private key encryption is typically, the public key infrastructure is typically the mainstay for whatever it is. But what is happening is, there are big companies, certifying authorities, right, who have been compromised today. So the PK infrastructure today, people are looking at alternatives. So one alternative is a distributed public key encryption. So when I say PKI, it is a distributed private key infrastructure where even if a single node is compromised, the others will kind of let you know that something has gone wrong here and then boot out that specific infrastructure. So since it is immutable in nature and you move all this information onto a network, which is a blockchain network, there is a possibility that even if it is getting compromised, you are able to recover most of the information. But having said all this, there is the KSI is keyless infrastructure. So all these are things which people are talking about today, and they are all pinning it with respect to the blockchain based solutions. So IAM is actually identity and access management. So how do I do that using a blockchain solution? So that is what people are talking about. Okay, so what I'm trying to say is that all these solutions are there today in the market, but then how do I bring in a blockchain flavor into it? How do I bring in immutability into it, into the existing stuff? How do I iron out all possible areas of failure? Okay.
DPKI will be floated around internet, right? Whether it will be encrypted as
Yeah, so any key infrastructure has got encryption.
So it will have a similar encryption as whatever we follow in blockchain, or?
Okay, so blockchain, there is a different encryption for the peer-to-peer exchange, which you will have to bear in mind. So this is only with respect to the key encryption. This is not with respect to the data part.
So then once who will decrypt it, because it is distributed across, only the person who is authorized to decrypt.
So anybody who's anybody who's a trusted agent on a network, right, has got the right keys to actually encrypt it and decrypt it.
Okay.
So it is taken care by the protocol per se. So you don't have to. So this is just the pipe. You're only talking about the pipe of it through which the info.
Dedicated tunnel.
No, it is always peer to peer. So between two people, it is always understood that these are the two parties involved, and it's always peer to peer.
When you mentioned secure information sharing,
right?
What do you do actually? Is it something like some algorithm, secure algorithm you share, or how's that?
It is. See, when you say secure information sharing, it is not algorithmic sharing. It is by virtue of maintaining the privacy. So only information which is required is shared, and what is not required is kept out of the network. So when I say secure information, what, for example, the information, am I sharing information about this employee which is not required to be on the network? So what it means is that I am sharing it, but I am sharing only the wanted information. I am not sharing the every hazard information which comes in, right? So it is about ensuring only the information which should go, that should go. So that is the secure sharing here.
Yeah, when it comes to critical infrastructure, any practical use case? Any practical use case which has been implemented on blockchain? See,
there are a lot of startups in this space, critical infrastructure, so especially the IoT space. Okay, so there's been experiments with the Tangle protocol and the IOTA network, but again, it's promising. So with the 5G around the corner, people believe that that's a space to watch out for. Okay, so we should wait for the 5G story to really kick in for getting more traction there. Yeah, IoT. Yeah, so why I say that's important is because it is kind of happening right now.
Blockchain and cybersecurity in IoT.
Yeah.
Blockchain, cybersecurity in IoT. How it will be correlated?
See, IoT is the end node. Okay, IoT is the end node of any device, right? So how do I actually make it available to people is what it is, right? So IoT becomes the end node through which you can make things available. So that's how you kind of say, for example, I have an end device which is a sensor or an IPTV. So how do I make that end device available, and how do I make this data of this end device, always onto the network? So the way I connect it is making that IoT device information as a device information, as a critical device onto the network. It's a cross check to your existing system. Not essentially as an IoT, it's not a replacement for your MQTT or protocols like that.
But there is a golden rule that anything connected to internet can be hacked.
Yeah. This is not about access to the device through blockchain. This is about information about the device. You get it? See, I have a detail of a device, whether this device is being used in this geography or not, right? I have something like a zero knowledge proof which I'll use to say that this device was not used there, right? So it is more like a cross check and not essentially not like a device information. So when I use IoT, I'm using IoT and I'm actually connected, right? So this is not getting into that space of the IoT messaging. It is getting into a space where it says, look, I have some information of a device in a geography. I want to run some sort of a proof whether this device was there at that point in time. So this is at a different time and space compared to what you talk about when you talk about an IoT messaging. It is about doing your analytics, it is about doing your proofs, it is about sending information whether this IoT device was there in that place, whether this sensor was operated in that place or not. This is like a history, it's like a post-mortem kind of a story. It is not like my real-time quick, your IOTA kind of quick communication. It is about, was this device in that place, was this sensor working at that time? Information like that is what we are using and doing some sort of a proof. and giving you information. So it is not that use case where you want to actually do quick communication between devices. It is about going back in time and figuring out whether things happened or it didn't happen or not. So you could create a heat map with using some of this pseudonymized data and then figure out whether something was there at that point in time or not. Yeah, so this is another use case where we are talking about a marketplace. So this is a marketplace where you have various security providers. So this is a marketplace, which is another use case which is there. The other one is about IDAM, which is about identity. This is about the sharing identity and information about the IDAM network. This is about threat information sharing. How do you share threat information across various organizations who are looking for threat information? This is about the secure data sharing use case which I mentioned, which is about different organizations. They want to keep private data private, as well as only what is relevant will be shared. SCAN is about source code attestation, which is where you want to kind of share information that this source code is from this specific person, it is original. So that's what this use case is all about. So if I have got open source code, can I actually go attest it, validate it? Do I know where the origin is? How was this open source code used? That is what SCAN network is. Here, one of the interesting aspect of a SCAN network is that you have algorithms like proof of commit. You got algorithms like proof of open source usage. You got even the license which is applied. So these are like, apart from your proof of work and proof of authority, the algorithm is actually conceptualized so that it can actually work on this specific kind of a network, right? So there are three parts: the core blockchain part, the off-chain components, and then the specific custom design consensus models that you can actually work on. So this is how you would kind of architect a service for a blockchain. So you will have various organizations, one which is generating the DID, which is a decentralized ID. It could be assets, people, source code, whatsoever. Push it into the blockchain network. You would have proofs of it created, like we just talked about the IoT kind of a proof. So you would have proofs created and pushed it into the blockchain network. So this is a rough example of how the platform could be laid out for this. So here is a base, and here is on the top what you have is nothing but the marketplace where you could build connectors, where you could have some of the trust networks that we talked about. So we talked about those three different trust networks. So one was for specifically, right, we talked about the source code, one for data exchange and one for identity. So those are the trust networks. For those trust networks, you can make custom apps. You can have the core of the platform here, so which again we are using all open source blockchain frameworks at the bottom, if you see. So you have all the Hyperledger, blockchain frameworks, like you have your Fabric, Burrow and all. So having said that, I would go to the last slide, which is about the future, where I believe strongly that open source is fueling these three things, right? So open source is fueling AI, it is fueling blockchain and cybersecurity, because that is what is actually getting all this technology accessible, available to a lot of people and a lot of organizations. Future is definitely there with respect to the three in the AI, the blockchain piece, and for all these initiatives that we are talking about, we are trying to start it as something where we want to get these networks out, get people on board. You're not alone in many of these things. You actually want to get a group of people in this. So which is where most of these initiatives that we are driving here are all open source. So you can go to our open source group and you can actually see we also have a SIG group for this. And we are also Hyperledger members, so we are seeding it into the Hyperledger Foundation as well, right? So with that, I would finish, and if there are any more questions, I'm open to questions.
Yeah, so with your last slide where you have mentioned about the future of cybersecurity and blockchain.
Right.
So I have a question that since blockchain is based on distributed ledger, where it believes in decentralization.
Right.
So same data going to a centralized server takes lesser CPU cycles than going to a decentralized network where it takes a lot of CPU cycles, and I believe it contradicts with the green computing concept where it says each CPU cycle saved is.
So, so I have a different answer to this, right? The purpose of blockchain is trust. Why do you take insurance? You're paying additional money for it, right? It's exactly the same thing, right? So why would you want to do this additional investment, right? And then the other thing is all blockchain frameworks are not proof of work. So there are different blockchain algorithms which you have, which are much more efficient. You know, everything is not proof of work, and there are better algorithms today which can do it more efficiently. Right? So yeah, so it's a valid point, but then there are alternatives.